I'm Riley Masters, and my ME305 project for this semester was an improved safety cut-down device for the BYU-Idaho High Altitude Research Team. The High Altitude Research Team is a student society that conducts atmospheric research using weather balloons. To comply with FAA regulations, unmanned free balloons, like the ones we use, need to have a cut-down on them, a device that, after a predetermined amount of time, or with some other trigger, will allow the balloon and the payload to separate. The cut-downs the team currently uses have a length of nichrome wire that burns through a rope running through them. In the past, they haven't always been the most reliable, so one of my goals for this project was to develop a more robust and reliable solution. Another goal of this project was to build some extra functionality into the cut-down by allowing it to be triggered by altitude as well as time. The balloons often have a fairly predictable altitude at which they will burst, and recoveries and descents are typically much smoother when the balloon cleanly separates from the payload. Here's a better look at the inside. The board I'm using to control the cut-down is an Adafruit ESP32 Feather. It's compact, powerful, and most importantly has Bluetooth capability, so that cut-down settings can be easily viewed and changed in the field by anyone on the team with a smartphone. These wires are connected to a BMP390 sensor. This takes pressure, temperature, and altitude readings during the balloon's flight. The altitude readings can be used to set an altitude ceiling for the flight, releasing the payload when the balloon is about to reach its estimated burst height. Mounted underneath the ESP32 is a real-time clock and data logger. The clock times the balloon's flight and makes sure the payload is released at the correct time. The data logger allows time, altitude, pressure, and temperature values to be written to a micro SD card for analysis after the flight. In the center is the release mechanism. The balloon will be connected to the spring-loaded mechanical archery release, and when it reaches its maximum flight time or altitude, the servo motor will pull the trigger, releasing the payload. This is all powered by a 3 AA battery pack and secured in a 3D printed box. Here's an example of how the device will be set up for flight. When the cut-down is on, done by flipping this switch, the sensor will show green light. Any Android or iOS device with a Bluetooth serial app can pair with and connect to the cut-down. Once the device is connected, the serial monitor will display this menu, showing the set release time, altitude ceiling, current altitude, and whether or not to log data and use the altitudes to trigger the release. All these settings can be edited through the menu. These last two options manually open and close the release, allowing the balloon to be connected. When the balloon is connected and ready to fly, the device can be taken out of setup mode. At this point, Bluetooth is shut off, the timer begins counting down, and the sensors will read and log data until the device is turned off or reset. Here's a demonstration of the release mechanism. When the balloon reaches its maximum altitude or flight time, which for this demonstration it will in about 5 seconds, the servo will open the release, wait 15 seconds, and close it again. Here's another demonstration of the release mechanism, this time using the altitude sensor. According to the menu, my current altitude is roughly 4,200 feet, so I'm going to set the altitude ceiling to 4,200 feet. When I disable the setup mode, it should release immediately. Now I'll demonstrate the data logging feature. When you remove the SD card and plug it into a computer, it will show up as this cut-down log card. When you open that, you'll see this data logs folder, which contains a text document containing the flight data. While this document should be cleared after every flight, just in case someone forgets, I've made sure that it will not overwrite any existing data, but just append it to the file. We have flight time, altitude, temperature, and pressure values for the entire duration of the flight.